Okay, welcome back, guys, and we continue the trig integral. But in this mini lectures, we just mainly focus on the integral that contain tangent and secant. And again, you still have tangent and secant to power of something. So you will come up with the techniques that help you deal with different situation. Okay, so the first scenario you may encounter is the powers of secant is an even numbers. Okay, the power of secant is an even number and it's even. Okay, so if you have n is even, I want you to save secant square and convert the remaining secant into tangent using this identity, secant square equal to tangent square plus one. Okay, and then you're gonna use the substitution for u equal to tangent of x. Okay, so let's try this one. Okay, so remember this this technique is applied when you have the power of secant as an even number. Okay, so you look at this one. The powers of secant is an even number. Okay, so you're gonna save secant square and convert the remaining secants into tangents. Okay, after that, you're gonna use the substitution u equal to tangent of x. Okay, so firstly, I need to save secant square. Okay, so that means I have to split the powers of secant. I have secant to power of 4x times secant to power of 2x because I want to save secant square. Okay, I want to save secant square. After that, we have to convert the remaining secant into tangent using the fact that secant square is tangent square plus one. Okay, so we need to convert the remaining secant. Okay, you're gonna save this thing. You're gonna convert the remaining secant into tangent. Okay, so firstly, remember that you just have this identity secant square of x equal to tangent square of x plus one. Okay, so if you want to convert secant to power of four, firstly you have to make secant square appear. It's pretty straightforward. Secant to power of four can be rewrite as secant square and then you square it. Okay, and like I said, we're going to save secant square, so we just rewrite things again. And up here, you can rewrite secant square as plus tangent square. Okay, and I still have the square outside. So remember to rewrite again the x. Okay, and now I'm sorry. This is the function in terms of tangent. So you can think this is the function compositions where the inner function is tangent of x. That is the inner function. And the secant of x is the extra things. So I would set up u equal to tangent of x because this thing is the inner function. Okay, this is the inner function that is constructed from tangent of x, which is the inner function. So I set up u equal to tangent of x. Okay, so when I do the tangent, when I set up u equal to tangent of x, that means du is secant squares of x dx. Okay, so the secant square of x dx up here. Now we can rewrite your integral into the integral in terms of u. So u is tangent of x. So tangent to power of 4 will be u to power of 4. Okay, I have u to power of 4. Up here, I have 1 plus tangent square. 1 plus tangent square. Okay, tangent tangent is u, so tangent square will be u square. I have 1 plus u square square. And secant square of x dx is du. So I have du. Okay, and now I can simplify my integral. So 1 plus u square square is 1 plus 2u square plus u to power of 4 du. Okay, you distribute u to power of 4 into the parentheses. You have u to power of 4 plus u 2u to power of 6 plus u to power of a du. Okay, and then you just pretty much use the power rule to finish your integration. Sorry. Okay, and if you have u to power of 5 divided by 5, you have 2u to power of 7 divided by 7. You have u to power of 9 divided by 9 plus c. And finally, remember to return your integration, the result, into the function in terms of x. And initially, we set up u equal to tangent of x. I mean, we have tangent of x to the power of 5 by 5. You have 2 times tangent of x to the power of 7 divided by 7. You have tangent to the power of 9x divided by 9 plus c. Okay. So this is the first case that might happen when you have the integral that contains tangent and secant. So in this scenario, um, if the powers of secant is even, then you're going to use this one. The next case, the power of tangent is odd. Okay, the power of tangent is odd. If the power of tangent is odd, then I want you to save secant times tangent and convert the remaining tangent into secant using the same identity. Okay, that means over here I have secant square equal to tangent square plus 1. So tangent square is secant square minus 1. Okay, so again, you see the integral that contain tangent and secant. Okay, and the power of tangent is odd, then I want you to save secant times tangent. Okay, convert the remaining tangent into secant, and then do the substitution u equal to secant of x. Okay, so up here, I see the integral that contains tangent and secant, and the powers of tangent is odd. Okay, so I will save tangent times secant. Okay, so firstly, I will split out my power. I have tangent to power of 4 times secant, sorry, times tangent. Okay, for secant square, I have secant of x times secant of x. Okay, and like I said, we're gonna save tangent times secant. We're gonna save secant times tangent. That's why I have to take one tangent from tangent to power of 4, and I have to take out one secant from secant square. Okay, so I have tangent to the power of 4x times secant of x. Okay, and I'm gonna save tangent and secant. So save tangent and secant. So I just write out it separately to emphasize that I'm gonna save them. I'm gonna save them. Okay. Okay. And what is the second thing we have to do? Remember to convert the remaining tangent into secant. Okay. So we need to convert the remaining tangent into secant. And like I said, we just have this special identity. Tangent square of x is secant squares of x minus 1. I mean, you are always able to go back and forth between tangent square and secant square. Okay. So if you want to convert this thing into secant, okay, that means you have to make tangent square up here first. Okay. So, and to make tangent square appear is not a big problem. You can rewrite tangent to the power of 4 at tangent square, and then you square it. Okay, and then you have tangent of x times secant of x dx. Okay, and tangent square will be secant square minus 1. So I have secant square of x minus 1, and then I square it times secant of x. And this is the thing we save. Okay, so this is the thing we save. So this thing gonna appear when you do the substitution. So just write that again. Okay, so this is the thing you're gonna save. This is the function in terms of secant. So secant is the inner function. I set up u equal to secant of x. And when I take derivatives of u, I'm gonna have secant times tangent. Okay, derivative of secant is secant times tangent. Okay, and this is the extra thing that you have in your integral that we intend to save initially. Okay, and so u is secant, so secant square minus u will be u square. I'm sorry, u is secant, so secant square minus 1 will be u square minus 1. I have u square minus 1, and then I square it. Secant is u. I just write it down again. And tangent times secant dx is du. Okay, now expand the square. I have u to the power of 4 minus 2u squared plus 1 times u du. Okay, I expand that. I have u to the power of 5 minus 2u cubed plus u du. Okay, and then we use the power rule to finish this thing. We have u to the power of 6 divided by 6. We have 2u to the power of 4 divided by 4. We have u squared divided by 2 plus constant c. Over here, actually, like 2 divided by 4 will give you 1/2. Okay. And we also need to return the thing that we have in terms of u into the thing in terms of x, because initially our integral is in terms of x. I have secant to powers of x. I'm sorry, secant of x to power of 6. 2 divided by 4 is 1/2. U to power of 4 is secant to power of 4x. Okay. And u squared divided by 2 is secant square of x divided by 2 plus c. So this is the strategy you should know if you look at the integral of tangent times secant to power of something, and the power of tangent is odd. So save secant times tangent. The last case you may have is what happens if m is even. So what if the powers of tangent is even? Okay, over here, I still have tangent times secant. Okay, and because the powers of tangent is even, okay, so the strategy is you need to convert everything into secant and use the reduction formula for secant. Okay, so over here, um, you have tangent square, and tangent square is secant square minus 1. This is the identity we have. Tangent square is secant square minus 1. So you have secant square minus 1 times secant cube. And you can have secant to power of 5x, subtract secant cube x dx. Okay. And this is the integrals of the subtraction. So it just turned out to be different between integral. You have secant to power of 5x, subtract secant to power of 3x dx. Okay, we have two separate integral. And from the reduction formula, you have you have the reduction formula for secant. So you're gonna apply the reduction formula for secant cube and secant to power of 5. Okay, so I leave that for you to practice. Okay, but actually it really much similar to the case when I do this thing. I have cosine to power of 4, and I decided that I want to use reduction formula. So you just write down the formulas, and then you determine that the power is 4, but in this scenario your power is 5 and 3. Okay, so you have to use reduction formula for these two things separately. One of them is 5 and one of them is 3. Okay, so this is how we deal with this is how you deal with the integral that contain tangent and secant. Okay, so again, you have to pay attention to the power of tangent and secant. Okay, so we can have more practice in the recitation video. Okay, so I will see you in the recitation video.